Hello, very good morning to one and all. Before we proceed our session, I request all to please keep your mic on mute mode, except the expert. And in between, if you have any query, I request all the participants to you can write on a chat box. At the end of the session, most probably all the queries will be answered. Okay, I'm Professor Robinson Paul, today's session chair. We will be helping you for the today's expert talk. I hope all you are doing well and you had a great session yesterday. It's my privilege to introduce our today's expert, Dr. Vijay Ukani sir. He is working as an associate professor with computer science and engineering at Nirma University. He has professional experience of over more than 19 years that footholds both academia and industry. He has received his BTech degree in computer science and engineering from SRTM University, Maharashtra, and MTech from computer science and engineering from MNIT Allahabad. He obtained his PhD degree in 2016 from Nirma University, Ahmedabad, in area of multimedia transmission in wireless sensor network. His research interest includes wireless sensor networks, Internet of Things, multimedia processing, and network protocol design. He has several publications as a conference paper, book chapters, journals, articles to his credit. He has worked on a research project funded by Good Coach and currently involved in a research project funded by SAC ISRO. Dr. Ukani sir has been invited by many institutions, industry to conduct workshops, seminar, lecture series on latest tools and technology. Now I request sir to have your valuable input on the title IoT in military application. Sir, you can present now.
Yeah, thank you. So, sharing my screen. Is it visible?
Not yet, sir. Yes, now it's visible, sir.
Okay. Okay, so good morning all. Today I'll be sharing my thoughts on some military applications using IoT. Just a moment. Yeah. So, like initially, once I was allotted this topic, I had two different thoughts in my mind. One is to summarize different applications where IoT can be used. In that case, probably I would have been able to describe abstract functionality of those applications. Is it? The other way of delivering this talk, what I felt is why not to talk about the challenges of IoT in order to develop a surveillance framework. Can I request other participants to mute because there is some disturbance? If you don't mind, I'll switch off my video because there might be some bandwidth issue.
Sure, sir.
So the second option was to talk about the IoT challenges, like in order to develop an application, military application, what are the challenges one will face, and what are the different solutions in order to deal with those challenges. This is how I planned my talk. So you can see that the title is rather than military applications of IoT, wherein I would have listed so many applications or so many deployments of IoT which are already in place or which are actually planned for military surveillance. I'll be talking about a specific application. The objective is to have a video surveillance architecture using IoT, because that also I will like try to compare what is the difference if I use a scalar sensor based IoT or what if I use video sensor based IoT. What differences does it make if I plan to deploy a system like this involving video transmission or having a IoT node having video camera basically? The complete requirement changes. So we'll try to talk about those challenges as well. So you can see that the title is Multimedia Surveillance Framework using IoT. And the agenda for the talk is I'll start by surveillance. What exactly is surveillance? Surveillance is actually some sort of monitoring, is it? And these are the kind of applications that we visualize probably in military. There are many other applications, but I'll try to restrict myself to surveillance application in the military domain. So surveillance, what is surveillance and how exactly it can be done? What are the different technologies that one can use for surveillance? What are the challenges, the framework, and some of the components of that framework? Is it in order to have a complete IoT application, we need to talk about all aspects of that application. You cannot simply say that I'm using Raspberry Pi board, attaching a camera, and I could capture the video stream. I'm done. No, it cannot be done like this. We need to look at all different aspects of it. Is it? So that I'll talk about as and when required. But basically in this talk, as you can see the topics, I will try to cover almost all aspects of that application design. A surveillance application is to be designed, and what are the different things that. And one more thing, my talk is slightly academic. In the sense, it is not from implementation point of view, but it is from design point of view. So you might get some research challenges also in this talk. You might get some problem to work on, research problem to work on possibly. So implementation specific nahi hoga. If I were to talk about implementation specific application, then I might have started with there is Arduino board, these are all the sensors, this is how to code, this is how you can organize your gateway, and this is how the communication will happen. Implementation hoga, but I'll not be talking about implementation aspect. But as and when required, I'll put some insight into the implementation also. So surveillance, as we know, it has become an integral part of life. Everywhere you find surveillance cameras in place. आप अपने सोसाइटी के बाहर निकलो, you will find that there are CCTV cameras deployed. आप रोड पे निकलो तो you will find that on every traffic junction you will find cameras deployed. Cameras of different quality, different range, different quality, and likewise, depending upon the application, we might have different kind of cameras. But this is need of the hour. Everywhere, almost every part of a city is normally covered with camera. Is it? So it is very critical nowadays in our life. The objective of a surveillance system is to detect or capture important events by using either scalar sensor or by using visual scans. So I'm not talking about only CCTV camera, because CCTV camera normally does not have any kind of scalar sensor. They only capture the video streams, is it? But it is possible to deploy a surveillance system which has scalar sensor. Scalar sensor in the sense I might have a thermal sensor, I might have a motion detection sensor, I might have ultrasonic, and likewise there are so many sensors. It can be a heterogeneous system containing scalar and visual sensor, yani ki camera sensor. It might be only scalar, it might be only visual, basically video sensor, and likewise. These are all possibilities of a surveillance system using IoT, is it? Because IoT, what do we have in IoT? We have a board, a programming board like Arduino, maybe RPi. Again, these are all general purpose boards. These are never used in application development. For application development, you need to build your own boards using some lower level microcontroller and likewise. So basically, we can attach any kind of sensors to this board and make the application work. And if you try to deploy a CCTV kind of application in your apartment, suppose, or maybe for traffic monitoring, or maybe for city surveillance, it is quite easy. Because we have power supply available, we don't need to worry about power supply. We don't need to worry about setting up the infrastructure. आपके घर पे या आपके सोसाइटी में, suppose if you wish to have the CCTV camera, you very well know the position. Okay, this is one place where I need to have a camera facing this direction. This is another point where I need a camera, and likewise. So you can plan your deployment. You can lay down the cables. You can have wired connectivity. You can have sufficient power available. No issues if you wish to set up this kind of application. But think about surveillance for military application. Think about Kargil. Think about Siachen. Is it? How difficult it is to deploy a surveillance system there? Can we deploy a CCTV camera? वहाँ एक पोल लगा हुआ है, उस पे जाके आप स्क्रू लगा दो. Wires are available, power supply available. No, it is not available. So for this kind of environment, the kind of IoT system that you would need, the kind of surveillance system that you would need will be very different compared to what we have in the societal applications, like apartment monitoring, traffic monitoring. They are quite easy, but this kind of environment is very different. So challenges in hostile environment are very long. The list is very long. The list of challenges, if I start listing, you'll find that there are so many problems. Is it? We do not have wires available. We cannot lay down the cables. We cannot provide power supply there. We cannot lay down the required infrastructure there in order to make the system working, and likewise. So hostile environment like national border, it is extremely difficult to set up the required infrastructure. So for this kind of environment, we need to have an ad hoc solution. Ad hoc means something like IoT, wireless sensor network. These are all the systems which can provide the ad hoc solutions. Wireless sensor network and IoT are predominantly becoming the most widely used technologies for this kind of applications. Surveillance, CCTV is very different. The video surveillance using CCTV, we cannot call it as IoT, we cannot call it as sensor network, we cannot, like there is nothing as such, dekha jaye to. But we are talking about altogether a different kind of application built using WSN and IoT. So before I get into the details, a quick look at wireless sensor network and IoT. So I got maybe 1 or 2 slides on each so that you can correlate whenever I talk about IoT, whenever I talk about sensor network slightly, you should be able to correlate. So wireless sensor network is a collection of sensor nodes which are very small in size, low power, and inexpensive because typical application might have thousands of sensors being deployed. So if the cost is very high, we cannot afford to have that kind of application. And that is why it needs to be inexpensive. Sensor nodes are low power multifunctioning device. Multifunction because we might have any number of sensors attached to it. So it can sense variety of parameters. Apart from that, it is capable of processing the sense data. It is capable of transmitting the sense data, and that is why they are multifunctioning devices. Operating in an unattended environment. Unattended CCTV surveillance is different because आपका कैमरा बिगड़ता है, you can always go there, screw down, उसको निकालो, replace करो. If there is a mistake or if there is a problem, you can repair it and likewise. So basically, it is an attended environment. But in sensor network or hostile environment like the national border, you may not be able to repair a node if it is malfunctioning. So normally they are operating in unattended environment with limited computation and sensing capabilities. They are not very powerful devices. So you cannot think of having a very complex computation being performed by the IoT boards. Okay. Self-organizing capabilities and cooperative efforts because sensor network and IoT communicates the data using multi-hop communication. And if it is multi-hop, they need to cooperate each other. Like something which is sensed by one sensor, one IoT board, other IoT board should be forwarding the data generated by this node. And they, in turn, they need to cooperate each other. Lifetime of a wireless sensor network, because they are all battery operated devices. Because थोड़ी देर पहले ही बताया था मैंने आपको, it is not possible to lay down cable and supply, power supply provide करना. And that is why these devices are mostly battery operated. If they are battery operated devices, we need to ensure that the lifetime of individual IoT nodes are prolonged. Because if the battery drains and आगे देखा था, they are operating in unattended environment. We cannot go there and replace the batteries. That node has gone. Is it? Once it is deployed, you forget about that node. जब तक चल रहा है, ठीक है, use it. The day the battery is drained, that node has gone. We need to ensure that the nodes are deployed in such a manner that our application continues to work if some of the node fails. So we need to ensure that lifetime of individual sensor node is prolonged somehow. Somehow में क्या हो सकता है, that we'll try to discuss. So basic objective is to ensure that energy efficiency of this kind of application is very critical. Okay. Sensor nodes sense and represent sensed information in numeric quantity. Like suppose I got a temperature sensor, it will sense something and the numerical value will be transmitted over a multi-hop network. There are chances that scalar sensors might suffer from high false alarm rate. There may not be an event. Suppose you have object detection sensor deployed. Like suppose you have ultrasonic sensor which can measure the distance to an obstacle. But the obstacle might be a piece of paper which is flying in the air. It may not be a object of interest, is it? So there are many such, like suppose I got a thermal sensor to detect human presence. But suppose there is a dog moving around, then also it will detect body heat of that dog and it will identify and it will let you know that, okay, there is something has been detected. Basically, these are false alarms, is it? So scalar sensor typically suffers from high false alarm rate. So solution is to add camera with the IoT boards. So if we can have cameras deployed in the surveillance system along with the scalar sensor, possibly we can reduce the false alarm rate because now we are in a position to capture the video contents If video contents or images are available, the chances of false alarm rate can be decreased. Okay, this is a typical architecture of wireless sensor network. You can see that these are all the sensors deployed. This is a sync node. Sync node is like a base station. This is user control node, when somebody who is monitoring the system, is it? And you can see user control. So basically user computer and sync node, they are connected by some sort of powerful network. So we don't need to worry about this network. We can assume that this is a kind of satellite network, or maybe a TCP/IP network, some sort of wired network, 3G, 4G, 5G, something is available. We don't need to worry about this part. Even in IoT also, we never worry about this part. The only thing that we need to worry about is this area of IoT. These are all the sensors, and you can see that anything detected by this sensor will be transmitted towards the sync node. This node is not in the direct communication range of sync, so it has to forward the data over multiple hop to the sync. The data just sensed by this sensor will be transmitted like this node. This node will forward it to the next node will forward it to the sync node. This is multi-hop communication. It is a typical architecture of a sensor network, and the same is the architecture for IoT as well. Okay, like if I talk about sensor network, don't think that the talk is on sensor network. It is IoT only. And there is no difference as such as far as sensor network and IoT is concerned. The only difference is that in IoT, every sensor, the same sensor, if I can assign IP address to the sensors, it becomes IoT. Typically in wireless sensor network, every node does not need to have a globally unique ID. But in IoT, it is expected that every node should have an IP address, typically IPv6 address, so that individual nodes can be addressed. That's the only difference. But otherwise, most of the things are same. The same set of MAC protocol will work. The same set of routing protocol will work. Same kind of applications you can build using wireless sensor network or maybe IoT. So next is, if I try to add camera or visual sensors into the sensor network, it becomes wireless multimedia sensor network. Wireless multimedia sensor network is a network of interconnected devices which are capable of retrieving multimedia content from the environment, such as video and audio stream. I might have a microphone, I might have a camera, so I'll be able to capture video, I might be able to capture images, audio stream. Apart from that, it is a heterogeneous network, so it might have scalar sensors also. So I'll be able to sense maybe temperature data, maybe some other kind of scalar sensors being deployed, and accordingly I'll be able to capture numerical quantities as well. Apart from that, because video sensors are deployed, video cameras are deployed, video camera, suppose video sensor or maybe IoT board connected with a camera captures a stream and transmits that stream. What happens if that stream is transmitted over this wireless network? This is wireless network, is it? If it is transmitted over these nodes, and these nodes are already battery operated devices, it cannot have powerful communication protocol. The transmission range of this node is very limited. The wireless environment is quite unreliable. Is it? These are all the characteristics of communication. I cannot afford to transmit video stream over such links because of huge bandwidth demand required by the video transmission. It is not affordable, is it? So I need to store, process, correlate in the sense process it and identify if there is some correlation between two video streams, suppress one video stream so as to reduce the amount of data which has been transmitted, and transmit multimedia data originated from heterogeneous sources. So basically I need to process the multimedia data within the network. And the objective of processing is to reduce the data rate requirement. Rather than transmitting 10 raw video stream, if I could process it within the network and identify that, okay, this 10 video streams are all correlated, transmitting only one stream is sufficient, then I can suppress rest of the 9 stream. Usko transmit mat karo. Ek ko hi transmit karo, because no new information is generated by 10 streams. One stream is sufficient to capture the required event. Suppose. In that case, I can suppress it. The basic objective is to reduce the bandwidth requirement and reduce the number of bits which are actually transferred, because every bit that you transfer in wireless sensor network or IoT consumes energy, and energy efficiency is very critical. Pure wireless multimedia sensor network supports line of sight capture, because if I have a camera, you need, like, we understand the difference between these two, is it? A scalar sensor does not have line of sight. A temperature sensor rakho, it can sense everything around it. 360 degree में वो sense करता है. But camera does not capture in 360 degree. वो उसी एक कोण में ही capture करता है the direction in which it is oriented. It can capture the contents in front of it, Anything happening on the backend side of the camera will not be captured. So this is called as line of sight capture. So pure multimedia sensor network supports only line of sight capture. So we can have a hybrid network of scalar and video sensor, in the sense have some camera node, have some scalar node, so that I can capture most of the things. And this is a typical architecture of multimedia nodes sensor network. You can see this is scalar sensors. These are some video sensors. This is a powerful node which is capable of processing. Then the rest of the things is like the sensor network. Then we have IoT is the third technology that we can use. IoT is a network of things. I suppose I don't need to describe what is IoT. So basically it is sensor network only. The only difference is that it has IP addresses. One more point is IoT is unification of technology. This we normally don't talk about in sensor network. Sensor network, whenever we talk about, we normally worry about sensors, we worry about MAC protocol, we worry about routing protocol, we worry about energy efficiency, and likewise. But when we talk about IoT, it is a complete application. Sense, transmit, process, process, analyze, take decisions. Is it? This is what is IoT. So IoT is actually unification of technology such as low power embedded system, yani ki your sensors, your processor board, etc. Cloud computing to store and process the data, big data, machine learning for analysis, and networking for communication. Is it? These are all the technologies or all the terms involved in IoT. But if I say that wireless sensor can also transmit data and that data can be stored on cloud, can be processed, machine learning can be used to analyze that data, then what is the difference between IoT and sensor network? Nothing. But when we talk about sensor, we only talk about this embedded system and networking. That's it. Cloud, big data, machine learning, etc. we don't talk about. Otherwise, it is there in wireless sensor network also. Okay. Real power of IoT. Why everybody is talking about IoT? Not because it is capable of sensing. Why we say that IoT is powerful? Because of the size of the deployment. It is visualized that by 2025, we might have few billions IoT devices already deployed in internet in this world. Think about the amount of data generated by these IoT sensors. So real power of IoT lies in the enormous amount of data which is generated. And now everybody knows that what is important is data. If you have raw data available, I can analyze it, I can process it, I can do anything out of that data. So nowadays, what is costly is data. And IoT is something which provides you that invaluable data, the sensors. And this is a typical architecture of IoT. These are things in the sense devices. You can see that these are 1, 2, 3 devices. This first box indicates a processor, or sorry, sensors and actuators. So I might have any kind of sensor. This is a processor, so IoT board is capable of processing, and this third component in the thing indicates the communication aspect of it. This is the local network, and IoT devices connects to the gateway via local network. In local network, there are so many technologies, so many MAC protocols suggested. जो आपको like in wireless sensor network जो मैंने बताया था, this is that local network. Gateway है, it is actually your sync node. So communication between your wireless sensor or IoT and sync node is to be controlled. I need to design MAC protocol, I need to design routing protocol for communication within this local network. Is it? Behind the gateway or behind the sync node, you can see that we have stable connectivity like satellite link, TCP/IP network, 3G, 4G, 5G, etc. On the backend side, I got cloud, your big data, machine learning, etc. is running on the backend services for analysis. Is it? This is IoT, and you can see that it is quite comparable to that of sensor network. Is it? Okay. So before we move ahead, since then I was talking about scalar sensor and multimedia sensor. So basically, these are the two categories of sensors typically. Scalar sensor produces output signal or voltage, which is proportional to the magnitude of the quantity to be measured, like temperature sensor, pressure sensor. Temperature value is not directional. आप ये नहीं बोलते कि इस डायरेक्शन में टेम्परेचर इतना ही है, मैंने इस पॉइंट पे सेंस किया, ईस्ट साइड में इतना था, वेस्ट साइड में इतना था. इट इज नॉट लाइक दिस, इज इट? इट इज अ डायरेक्शन लेस क्वांटिटी, so it can be sensed with a scalar sensor. Similarly, if I got vector sensor or multimedia sensor, it produces output signal or voltage which is proportional to magnitude, direction, as well as orientation of the quantity to be measured. So basically the capture is directional here. For example, sound sensor, image or video capture, camera sensor, etc. These are all multimedia sensors. What is the difference as far as the coverage is concerned? We call it as event coverage, is it? Look at this. This is of a camera. Like suppose P, X, Y. X, Y is the position and P is the point where a camera is located. V, this vector V indicates the direction of camera. So your camera is placed like this. Then the triangle which is formed, it is two-dimensional diagram, so it is triangle. But in 3D, it will be like a cone, is it? So this is called as FOV of a camera. FOV stands for field of view. Field of view of a camera, and this P to this line, this distance is called as depth of view. The distance up to which the camera can capture clearly. And the angle of this cone or angle of this triangle is called as angle of view. Okay, and this triangle PBC, this triangle is called as the FOV or field of view of a camera. Now, look at the event coverage of a scalar sensor and a video sensor. Look at this. This is your scalar sensor. Suppose this all circles indicates scalar sensors. The dotted circle is actually the event radius from the center. That center is nothing but the event point. This is the point where some event is happening. And we are interested in capturing that event or identifying that event. These are all the sensors which are deployed. So you can see that any sensor, scalar sensor present within this event radius will be able to detect that event. You can see that they are indicated with bold circles. Bold circle means these are all the IoT boards which have detected that event. But look at the other IoT sensors. These are all other boards. They could not detect that event because they were far away from the event. They were behind or they were outside the event radius, could not detect it. But you can see that direction does not matter in case of scalar sensor. Look at video sensor. Center is again, this star indicates the event. Event radius here is quite large compared to that of scalar sensor because camera can capture contents from a quite large distance compared to a scalar sensor. Look at the deployment of this cameras. And this line indicates, this actually tail indicates the direction of camera. You can see that this camera is very close to the event, but it is oriented in a different direction, could not capture it. Whereas this camera is quite far away compared to this, but it was oriented in the event direction, it could capture it, and likewise. So I hope you are getting it. You can see that deploying camera is not sufficient. Deploying camera in particular direction is required in order to capture an event. Can we plan this deployment? You might wonder, why am I talking about these things? Coverage model and scalar sensor coverage, video sensor coverage. Think about that situation. The environment is hostile. You cannot go and fix your camera in a particular position. You do not have a pole, you do not have a wall available. जहां आप screw करोगे, you cannot plan your deployment because we are talking about a surveillance framework for hostile environment. We are talking about military applications. Think about Kargil, is it? So that kind of environment, it is not possible to deploy camera. Then what is the deployment plan? How exactly you can deploy? How many of you have seen that movie, Twister? It was released in 1994, 5, roughly maybe 96. I don't know exact year, but somewhere close to 95. In that movie, it was shown that some scientists were interested in monitoring some of the parameters of the twister. The deployment was, they have like put thousands of sensors in a car and deployed that car or parked that car in such a manner that the twister, it is on the way of that twister. Is it? Finally, those sensors, like somehow the twister came and from that car, most of the sensors have started moving along with the twist. And the sensor parameters, those sensors could monitor the parameter. What was the deployment? Was it an engineered or planned deployment? No. The other possibilities, like suppose forest fire monitoring, how to monitor, how to deploy sensor, the given application is forest fire monitoring. One of the simplest and possible approach is throw all the sensors from helicopter. Let it fall in whatever manner it falls. But the sensor should have self-organizing capability. They should be able to form the network between themselves, capture the things and start transmitting. We cannot engineer the deployment in this kind of application. So here also the deployment we are assuming is, it is not engineered, not planned. It is a random deployment. If it is random deployment, we cannot guarantee that the sensors, the orientation of camera kaisa hoga, in which direction they are facing and likewise. And that is why we need to worry about event coverage. What are the challenges if you use this kind of network? Resource constraint, like one might wonder why every now and then I'm talking about resource constraint. You might say that I got a RPi board with 4 GB RAM. I got a Arduino board which is quite powerful. But do you think that you can build a real application using Arduino? Real application using RPi? No, RPi, Arduino, they are all general purpose board, only for laboratory testing of the application. Once you think about building an application, you cannot use RPi board, you cannot use Arduino. You need to build your own boards, is it? Very small boards, battery operated devices. So again, those resource constraints, etc., will be there. You cannot discard this characteristics of unique characteristics of IoT board. Limited energy reserves, unreliable network, limited processing capability in memory, because the boards are not very powerful. You need to design your board for a specific application which is just sufficient to fulfill the requirement of that application. Because powerful the board, more is the capability of that board, more will be the power consumption. And I cannot afford to have a board which is consuming battery, consuming huge amount of energy and drains your complete battery within 15 days. It will not work. If something application is deployed, I expect that the application should work at least for next 6 months or a year. So I need to ensure that the battery lasts for at least 6 months to 1 year, depending upon the application and depending upon the kind of sensors that you have deployed. Is it? Lack of engineered deployment, something which I described on the previous slide. Is it? These are all the challenges. If I start introducing video or camera into it, the set of challenges will change. Application specific QoS requirement, quality of service. It is a very critical and very important parameter in order to get video streams or audio streams. Like if YouTube streaming karte, at that time also you might expect some characteristics from network. That jitter nahi hona chahiye, I should get continuous playback. There should not be any kind of pause in the playback, and likewise. This is something that we expect from the network. Then don't you think that you will expect something here also? You have a video surveillance network, and if the video transmitted is not up to the mark, it is delayed, it has jitter, some of the frames are lost, will not work. So I expect some kind of QoS here also. How to provide is a big question mark. High bandwidth demands, because we are talking about video transmission now. Multimedia encoding, it is a big domain wherein one can contribute. I cannot use MPEG like encoding in this. अपने RPi पे कभी सोचा नहीं. You use Pi camera, connect it to RPi board, start capturing the video stream. But have you ever wondered what kind of encoding algorithm is running? Raw video captured by camera is to be encoded before it is transmitted. Raw video transmission cannot be done. The reason is huge bandwidth requirement. So multimedia captured is to be encoded. What do you think? Have you ever tried to figure out what kind of encoding algorithms are running on RPi or running on the camera, and how complex those algorithms are? So multimedia encoding is a big challenge. Multimedia in-network processing. In-network processing, just something which I talked about. Correlating the frames, identifying whether the video stream is important, whether it carries some meaningful or important information about the event. If yes, then transmit. If no, then suppress it, and likewise. So basically, in-network processing, within network processing. Field coverage, which I talked about on the previous slide. This is your field coverage. You can see that field coverage itself is a challenge in case of video sensor network. So before I move ahead, is it fine with you if I move like this at this speed? Because look, I'm not here to spend 90 minutes. I just want to ensure that you have some takeaways from this session. So if you have anything for me at this point of time, I can mold the content, mold the speed, etc. accordingly. So some feedback will help me at this point of time.
Speed is perfectly fine, sir. Please go ahead.
Okay. So if you feel that something is something I can adapt, let me know. I don't want to make it one directional session. Okay. So these are the challenges. Now, somewhere I talked about video encoding. मैंने आपको पहले बताया था. I'm not talking about implementation. So this session is not from implementation point of view. अगर implementation होता, तो nobody will talk about video encoding. They will talk about Pi camera, RPi, how to connect, which library is to be used, which Python library is to be used for coding on RPi, how to capture, how to transmit. That's it, is it? because this session is not from implementation point of view, I'm getting into something which we as a computer or EC engineer are supposed to work on. Coding, implementing is something which normally students or somebody who is new in this domain does. But as being the scientist or the researcher in this domain, we need to worry about this aspect of IoT design. Start thinking about video encoding. What are the different challenges that one might face if I wish to encode the video? Assume that you have a Pi camera, you have RPi board, but RPi does not provide any kind of code to deal with it. You are supposed to code it. How exactly will be coding it? So I'll be talking about some of the challenges that one will face. Conventional video encoding techniques like predictive encoding. You might be familiar with multimedia encoding, video encoding. Predictive encoding is something which is used by many traditional multimedia encoding techniques like MPEG, H.264, 263, and likewise all variants of H.26X basically. Predictive in the sense it has three different kinds of frame: I frame, P frame, B frame. I is intra-coded frame, P and B are reference, they are dependent frames on I. And predictive encoding is also used by using motion compensation and motion vector estimation and etc. These are all the things which goes into video encoding. But this is very complex to implement. And that is why predictive encoding kind of techniques are not suitable for resource constrained nature of IoT. Because these are typically meant, MPEG and those things are meant for the applications like encode once, decode many times. So basically you can encode a video, put it on a pen drive, copy it on a CD or DVD, encode it, and encoding is done only once, then it is written on the DVD. You decode that DVD thousand number of times, but decoding should be easy. Decoding should be simpler. Encoding can be complex. Why? Because it is happening only once. And that is why for applications like this, where we need encoding once and decoding many times, this kind of encoding technique works. And we have powerful computers to encode. So no issues at all. But in IoT, we do not have that luxury available. If I got an IoT board, I got a camera, where exactly we encode? The IoT board itself is responsible for encoding the video before it is transmitted. Can I afford to encode such kind of video using such kind of technique on IoT board? You cannot. We do not have RPi-like board, remember. Okay. One more thing that you might have heard if you have worked in network or multimedia communication ever, you might have heard this number of times, that energy required to transmit one bit. Remember and try listen to this statement. Energy required to transmit one bit is 1,000 times greater than energy required to process 32 bits. I can give citation also, I can give you paper also which claims this and which proves this. So the amount of energy required to process 32-bit, amount of energy required to transmit one bit wirelessly is 1,000 times greater than the amount of energy required to process 32-bit word. Is it? What is the conclusion based on this statement? That the only scope of energy optimization is in communication protocol design. Processing में much energy is not being spent, so there is not huge scope of improvement. The scope of improvement lies only in the communication aspect. Design your routing protocol, design your MAC protocol, design your communication system in such a manner that it is energy efficient. But several experiments were performed by Ahmed in this paper, so at the end you will be able to find this reference, showed that DCT based intra-coded frames, यानी कि something which is used in predictive encoding, जो previous point में बताया था मैंने, intra-coded frames consume 98.5% of the energy in encoding, while only 1.49% is consumed in transmission. Look at this, it is exactly opposite of that statement. 98 to 99% of the energy is consumed in processing, that is encoding, while only 1.5% is consumed in transmission. So जो statement मैंने बताया था, it is not true for multimedia encoding. For normal scalar processing, it may be true, but for video processing, it is not true. You can see that the major component is this 98.5% is for encoding. So I cannot afford to have DCT based encoding where 99% of the energy is only spent in encoding, is it? And likewise. So this is not true for video encoding. So in order to deal with this, I need to have a lightweight, low complexity technique which can encode the video, is it? Apart from that, we are suffering from high bit error rate of wireless environment. There are several suggestions. Use ARQ, that is automatic repeat request. FEC is forward error correction. Use some kind of error correction technique just to ensure that there are no retransmissions, because retransmissions are very costly. If a frame is lost, you retransmit it. The efforts and energy required to retransmit the frame is very costly. I cannot afford to have ARQ. So use FEC, forward error correction, or use ERC, that is error resilient coding, something like multi-description coding, MDC, wherein multiple description of the video is sent. If some number of descriptions are received, I'll be able to generate acceptable quality. More the number of descriptions received, better will be the quality. But if some of the descriptions are lost, then also I can have acceptable quality of the video. Is it? Similarly, we have layered coding. It is also kind of adaptive coding or error resilient coding. So these are some of the suggestions for video encoding for low power network like this. Predictive encoding uses motion compensation based encoding, which is very complex to implement on low power IoT or sensor boards. One more suggestion was to use a distributed video coding, DVC based WZ encoder. You are from EC, so you might be better aware about this. Wiener's encoder, it is the most suitable for this kind of devices, as the complexity is shifted from encoder to decoder. So it is exactly opposite of encode once and decode many times philosophy. यहाँ पर encoder is simpler and decoder is complex with WZ. And this is the kind of system that we expect in low power boards. The complexity of encoding should be minimal. Decoding complexity high हुआ तो चलेगा. Why? Because where exactly you are decoding the streams? Maybe on that user computer, a powerful computer where you are monitoring, there you are supposed to decode. There we are not worrying about the resources. We are worried about the resources on the IoT board side or the sensor nodes side. So there we need to ensure that the complexity is minimal. Routing protocol, I don't know whether you had any session on the protocol stack of IoT, but I could see during your schedule that you had one topic on protocols. So you might have heard of these protocols. RPL is the default routing protocol for IoT. Default because it is standardized. Is it? Baki, otherwise most of the routing protocols suggested are non-standard protocols. But RPL is a standardized protocol which is used in most of the IoT implementations. But RPL is not for specifically built for, it is not specifically built for multimedia support. Can I ask one question? Do you think that I need to have a different kind of protocol to support multimedia, different kind of routing protocol to support multimedia, or the same traditional routing protocol for multimedia will do? If at all I need something different, what is it that is to be used? Something is to be redesigned. Yeah, can somebody try to answer?
The routine protocol may not function here properly because the data which we are handling, the size of the data is very high, and we need to analyze with the faster rate.
Okay. Okay, so you are basically talking about data rate and the amount of data. Okay, that's fine. But in scalar application, like I got a scalar sensor and I got a routing protocol, there also I can assume
multimedia video capture, that images and all that will require the encoding and decoding should be handled properly. So larger bandwidth and the faster rate will be much more convenient for.
Okay. So you might have seen something like QoS, quality of service provisioning in internet. There are so many techniques used in internet for congestion control, for prioritizing the traffic. Is it? Because multimedia transmission is normally real time in nature. If it is real time, we need to ensure that routing protocol deals this packet, multimedia packet, with care. Packet should not be delayed, should not be queued, should be processed as fast as possible, and likewise. So basically some kind of quality of service awareness is required. QoS awareness is required by the routing protocol, is it? Then only they'll be able to handle the multimedia traffic as per the requirement of the application. RPL is not specifically built to support multimedia. It is basically a best effort protocol, and best effort protocol normally does not work well for multimedia transmission. There are many other suggestions based on RPL. They are co-RPL, CORPL, or cognitive RPL. Then we have CARP, channel aware routing protocol, enhanced channel aware routing protocol, etc. These are all non-standard. Non-standard in the sense they are all suggested, they are not yet standardized, but these are all some of the protocols suggested for RPI, suggested for IoT. Most of the suggested routing protocol uses, again, something which works well for multimedia or for IoT kind of network is geographic routing protocols, or they are also called as location aware routing protocols. Is it? Because we need a lightweight protocol. IoT के लिए anything that we design has to be lightweight in nature. So the routing protocol that you design should also be lightweight. Lightweight in the sense the kind of routing table it maintains should be minimal. But otherwise, if I say that I got an IoT network of 10,000 nodes and I'm using a routing protocol like RIP, which is based on distance vector DV, then the size of routing table will be there are 10,000 nodes. Every node is supposed to maintain information about rest of the 9,999 nodes. So the number of entries in the routing table will be almost 10,000. But the memory is limited. Can I say that I'll be able to store those 10,000 entries in the memory available with me? No. If you look at some of the characteristics of this low power devices, the memory available is in terms of few kilobytes. RAM is few kilobytes, ROM maybe few hundred bytes, few hundred kilobytes. I cannot afford to store those 10,000 entries, is it? So I need to have a scalable and stateless routing protocol. Stateless in the sense something which does not maintain a routing table or detailed routing table. And that is why geographic routing protocols or this class of routing protocols are better for this kind of network. But problem, because I'm not maintaining any state or routing table, this kind of routing protocols are greedy in nature. That is, they make locally optimal decisions. Global path nahi dikhta, but ye dikhta hai ki okay, this is my best node. They do not worry whether that best node will take you towards the destination or not, and likewise. So they are greedy in nature. And apart from this, energy efficiency is also a big issue. With most of the routing protocol, the control overhead, like distance vector routing की बात करो आप या RIP की बात करो, the RIP update interval is 30 seconds. So every 30 seconds, they are all supposed to exchange. Every router is supposed to exchange distance vectors or RIP updates with each other. और मैंने आपको थोड़ी देर पहले ही बताया था, every bit that you transmit is costly. It is consuming energy. If you keep on exchanging information, the routing tables are exchanged every 30 seconds. Almost all your energy will be spent in maintaining the routing table. Forget about transmitting event information. Is it? So this kind of complex algorithm or this kind of algorithm which has high overhead will not work. Is it? So energy awareness is a big issue with most of the routing protocol. Apart from that, multimedia packets bear different importance. थोड़ी देर पहले मैंने बताया था कि IPB frame suppose. I frame is very important. P and B may not be that important compared to I frame. Because if I frame is lost, subsequent P and B frame may not be of that use. And that is why you need to protect your iframe. The basic objective is to provide different importance to different frames or different packets. Your routing protocol should be capable of handling the packets differently. Is it? इस पैकेट को मुझे अच्छी तरह ट्रीट करना, इसको थोड़ा lightly treat किया तो चलेगा. Something like this. But the routing protocol should be capable of doing it. So multimedia packet bears different importance. So differential treatment to individual packets are required by the routing protocol. Okay. Does it make any sense? Have you seen the protocol stack? I suppose yesterday you've seen the protocol stack. At the top it has your IoT management, then you have application layer where protocols like MQTT, COAP, SMQTT, XMPP and likewise were running. उसके नीचे क्या था? Application layer के बाद आपका network layer था. Network layer was IPv6. उसके बाद you had MAC layer. Between your network layer IPv6 and MAC layer, you had something called as adaptation layer, IPv6 6LoWPAN. Is it? 6LoWPAN is the adaptation layer which you use between network layer and the MAC layer. What is network layer? This is your routing protocol is something which works at network layer. So you cannot discard routing protocol as such. Is it? So routing protocol has some space in the protocol stack. Similarly, the next slide which I'm going to talk about is MAC. MAC also you cannot discard. You have already talked about some of this. You might have heard of some of these topics in maybe one of the session. Most of the sensor platform uses IEEE 802.15.4 based MAC. This is the most widely supported MAC for IoT. Was it 15.4? और इसी के लिए आपने 6LoWPAN यूज किया था. IPv6 का size is very large and The payload offered by 15.4 is very small, so you need to compress your IP packet, and for compression we need 6LoWPAN. Is it? So 15.4, it is actually Zigbee. Zigbee आपने सुना होगा. So it is actually like Zigbee. It is one of the most widely used MAC protocol for all IoT developments. It is a low power best effort MAC protocol, and best effort MAC protocol does not work for multimedia. Any best effort protocol does not fare well for multimedia transmission. So some variants are required. So you can see that 802.15.4e is an enhanced version of 15.4. Is it? This is a low power communication protocol which enables high reliability and low cost communication. This is slightly acceptable compared to 15.4 for multimedia. Apart from that, you have other options like 802.11e. E is again enhanced compared to 11. 11e is enhanced in terms of the QoS support, which is provided by 11e. It uses multiple queue with different parameters to support differential handling of the frame. 11e maintains a single queue. 11 maintains a single queue. 11e maintains multiple queue. So different priority packets are placed in different queue, and the way the packets are handled from different queue is different. The first queue is important, second is secondary, third is ekdam low priority, and likewise. So accordingly, you will place your packets in different queue, and the MAC will try to transmit the packets accordingly from different queues based on the priority. So this is how it can offer some level of quality of service. So 11e is still acceptable solution, but the problem is it is difficult to have IEEE 802.11 or wireless LAN or Wi-Fi running on IoT boards because of the power consumption. 15.4 is a very low power solution. Typically 15.4 is used in IoT. 11 rarely used. Okay? But still it is an option. There is one more variant of IEEE 802.11, AH. AH is specifically meant for IoT. So it is the least overhead version of IEEE 802.11 standard or 11 family. This family में सबसे low overhead protocol is 11AH. It is specifically meant to fulfill the requirement of IoT. Okay? So 11AH is also an alternative. There are many other MAC protocols that you might have heard of. You might have heard of wireless HART, you might have heard of Z-Wave, you might have heard of Bluetooth Low Energy or BLE. These are all the protocols which you can list under MAC protocol, but I don't want to get into the communication MAC only, and that is why I've restricted myself from listing those protocols. Most of the MAC protocols provided variable QoS by varying the protocol parameters. Suppose if at all you wish to provide QoS, you need to play with some of the parameters, and these parameters are to be adjusted dynamically. So you can always have a MAC protocol which works dynamically by controlling the MAC layer parameters. Is it? So MAC layer parameter को अगर आप properly tune कर पाओ तो you will be able to offer some level of QoS. So this is one area of research which you can get into. Study this, how different protocols are varying the parameters, what algorithm can be used to vary this parameter in the most efficient manner. Something like this you can work on. Again, this is for IoT only. Okay? So MAC protocol, these are all the challenges, is it? So MAC पे you have something to do, network layer routing पे you have something to do, sensors पे, उसके capture पे, multimedia encoding is something where you can contribute something. These are all the challenges where still there are some problems. If I talk about surveillance as an application, then what are the problems that you will face in the application? Now I'm not talking about technology. IoT की challenge की बात नहीं कर रहा हूँ. I'm talking about surveillance challenges. Some of the probable surveillance technologies, like, again, I'm talking about national border like Kargil or that kind of environment, is it? So what kind of technologies you can deploy for surveillance, like laser wall, thermal sensor, tunnel detector sensor? If nothing is possible, UAV is always an option, is it? Then you might argue, then why not to use UAV? Why one should worry about IoT, video-based IoT? UAV is unmanned aerial vehicles, is it? So basically it is like your quadcopter deployed with a camera. But what is the coverage? If an event happens, you may not have a UAV deployed at that point. UAV is to be controlled manually, is it? या आप ऑटोमेट भी कर सकते हो उसके अंदर इंटेलिजेंट एल्गोरिथम लगा के, दैट्स फाइन, बट इट कैन रीच एट द इवेंट लोकेशन एंड कैप्चर द डिटेल्स. बाय दैट टाइम द इवेंट माइट हैव गॉन, is it? Something wrong might have happened. So UAV is a good solution but may not be the ultimate solution, is it? Deployment feasibility, like talking about this technology is easy, but is it feasible to deploy this kind of technologies? Given that the environment is very hostile, वहाँ पहुँचना difficult है humans के लिए, machineries पहुँचाना और जाके deploy करना is extremely difficult, is it? So deployment feasibility, cost of UAV is very high. You cannot say that मैं 1000 UAV लगा दूंगा और मेरा पूरा border cover हो जाएगा. Look at the cost. It is one factor which we need to worry about. And region coverage of these technologies are questionable. So like listing this technology is easy, but deploy करना उसकी cost, वो कितना region cover करता है, it is not very straightforward. Due to hostile environmental condition, deployment of such technology may be extremely difficult. Engineered deployment possible नहीं है. Surveillance system which can be deployed in ad hoc manner is required. Is it? Most of the proposal using IoT for border surveillance or for this kind of surveillance insist on using scalar sensors like metal detector use करो, thermal sensor use करो, tunnel detector use करो, etc. ठीक है, fine, but वो मैंने आगे already justify किया है. This sort of sensors suffers from high false alarm rate, and that is why we need to add camera into it. So surveillance using camera-based IoT were mostly based on plant deployment, and there are few proposals which is already there in literature based on camera-based IoT network, but most of them assume that the deployment is plant, and we already justified that for this kind of environment, the plant deployment may not be feasible. So we need to design a framework which supports random deployment and still works well. So random deployment poses a new set of challenges like coverage redundancy. What is coverage redundancy? It is a new challenge now. If we deploy the video cameras randomly, it is possible that two cameras are like you are dropping it from helicopter, suppose. After you have dropped it, suppose they are positioned in such a manner that there are two or three cameras which are capturing the same area, because usko गिरे ही उस तरह से है. They are positioned in such a manner that they are all capturing the same area. If an event happens, all the three of them will capture. Don't you think that it is redundant capture? All three of them are spending the efforts to capture. They are all encoding, they are all transmitting. Ultimately, आपको एक ही चीज के 3 वीडियो मिल रहे, which is of no use. Only one is sufficient. So, how to identify the coverage redundancy? This is called as coverage redundancy. That is, the same area is covered by multiple sensors. It is called as coverage redundancy. How to identify the coverage redundancy? Based on coverage redundancy identification, can I duty cycle the nodes? I hope you understand what is duty cycling. Duty cycling is the amount of time for which the node is working. Basically, it is ratio of the time for which the node is actively working upon the time for which it is sleeping. And I want to reduce the duty cycling. Given, is it? Like if I know that in the previous example, I had an event, but 3 different cameras were capturing the same content. Somehow using some algorithm, if I could identify that ये एक camera चल रहा है, तो बाकी दोनों camera can go to sleep. Because one camera is already capturing. If an event happens in that area, it will be captured by this camera. Why other two should be actively monitoring that area? I can ask the other two to go to sleep. Is it? Because I am duty cycling the nodes based on the coverage redundancy. Does it make any sense? Yeah. Hello. Hello. Yeah. Any input? Any question till now?
No, sir. No, sir. You can continue, sir.
Okay. So look, the surveillance framework which we are planning to, which I am suggesting or which I am proposing in this talk, the objective is to design an IoT-based video surveillance framework. Is it? Look at the environment and accordingly look at the objective. IoT-based video surveillance framework which supports random deployment. I have already justified that we need random deployment, is it? So I need to have a framework which supports random deployment. Identify coverage overlap, something that I talked about just now, coverage redundancy, coverage overlap. So if I could identify the coverage overlap, then I can exploit it in the duty cycling of the camera nodes. Duty cycling is one of the most powerful approach to save energy. Okay. So duty cycling the camera nodes, the camera will decide whether I should be actively capturing or I can go to sleep, something like this. And it has to be done dynamically using some algorithm. Adaptively capture in the sense capturing again, how many times you have played with camera? Played in the sense you have worked with camera parameters. What are the different parameters of camera that you can configure or you can set? Can I set the frame rate of a camera at the time of capturing? Can I set the resolution of camera at the time of capturing video? Is it? These are some of the parameters that you can play with. Smaller the frame rate, lower will be the quality. Lower the resolution, lower will be the quality. Higher the resolution, higher will be the quality. Can I adjust these parameters accordingly or dynamically based on the requirement? So this is one thing which we have done. Duty cycling the camera node and adaptively capture. Adaptively in the sense, adapt this parameters dynamically and based on that capture, encode the video stream. Encoding is also done adaptively. We'll see what is so dynamic in the video stream encoding. And communicate the content in energy efficient manner within delay bound. Delay bound in the sense, this is a QoS requirement that timely delivery is critical. So these are all the sub objectives, or we can say small tasks. Design a surveillance framework for scenarios where pre-engineered deployment is not possible. So we need to design a framework which can work in environment where pre-engineered deployment is not possible. Develop methods for computing the overlap. जो आगे बताया था, overlap या coverage redundancy. The question is how to identify coverage redundancy. So we need to have an algorithm which can identify coverage redundancy. Develop adaptive capture algorithm. So what kind of algorithm should be running so that it encodes the video dynamically? Identify frame rate, identify resolution, identify the GOP length, the number of I frame, P frame, B frame, etc. if at all I'm using it. और जो वाइनरजी बताया था उसमें भी there are key frame and WZ frame. So similar kind of structure also exists in WZ. So there also we can adapt or we can dynamically decide when to introduce I frame and likewise. Develop energy efficient routing protocol which are capable of delivering multimedia packets. Design a QoS based MAC protocol to support diversified requirements. So you can see that this is the requirement of complete application. If you wish to develop this complete application, these are some of the things that you need to look at. Is it? You can see that starting from application layer and capturing and video encoding to communication, including routing, MAC, everything covered. So this is a complete framework, complete application. In order to design complete application from research point of view, these are some of the things that you need to take care of. So some of the assumptions that we are making for that framework to work. First is, every node is assumed to be equipped with accurate location finding system, something like GPS. You might argue that GPS accuracy is not very, very high. It is in terms of 4 meters to 10 meters is the accuracy. But if you search millimeter GPS on Google, you will be able to find that there are highly accurate positioning systems available, which can provide you millimeter level accuracy. Is it? So we are making the assumption that we have millimeter level accuracy available for every node. This is required for localization. So whenever a camera node or any IoT board is deployed from helicopter, at least we are assuming that every node knows its own position by using this kind of system. Second is, in order to control power, we are using per packet power control. Is this possible? Anybody? You are from EC, most of you are from EC background. So I suppose you might have worked with this sort of transceivers. Have you worked with CC2420? TI CC2420? Anybody? Okay, so this is a transceiver which permits you to control the power level. There are 31 power levels supported by CC2420. You can decide one of the power level that I want to use power level 31. इसका मतलब transmission power इतना use होगा. Use power level 0, lower transmission power will be used, and accordingly the communication range that you can achieve will be smaller because you are using lower transmission power. But it is possible to program CC2420. There is a parameter called as PX power level. You can play with this parameter and you can control the power level for every packet, like transmit this packet at power level 31, transmit the next packet at power level 2, and likewise. That you can do. Is it? So it is possible. We are assuming that the transceiver supports the transceiver which is used, and CC2420 is a 802.15.4 based transceiver. जो आगे हमने देखा था 15.4 MAC 2420 supports. It is actually a Zigbee based transceiver. ठीक है? So it supports power level. per packet power control is possible with CC2420, and many such transceivers supports this. Look at the network architecture. These are all your IoT boards. Maybe do alag dikhaya because maybe this is using suppose thermal sensor. This is a slightly different image is used to indicate that it might be using a different kind of sensor. So you can see that, and this camera CCTV dikhaya, but it is not actually CCTV. It is IoT board with camera. You can assume that it is a Pi with Pi camera. But these are all camera boards, sensor boards, and likewise scalar sensor. You can see that the architecture is quite heterogeneous in nature. All different kinds of boards are integrated into the application, is it? And this is your multimedia processing node. Multimedia processing node is a powerful node which is capable of processing the video data. So here we can assume that this is a powerful node. Sufficient battery is available, sufficient processing power is available. They are powerful nodes, is it, for in-network processing. This is something, this is the kind of architecture that we are thinking of. So I've already explained this. Okay, multimedia processing node is a powerful node, resource-rich node capable of processing the video. So that we already explained. Look at the protocol stack running in that video node. So video node, here I have MAC protocol on top of it. We have routing protocol on top of it. We have application layer, and look at the application layer. The application layer has a component for coverage redundancy, or coverage overlap. So this is a piece of algorithm running to identify the overlap. Adaptive frame capture. This component identifier, or this block identifies the frame rate and resolution at which to capture the contents. Video encoding is responsible for dynamically adapting the video encoding. Dynamically encoding karna hai aapko, is it? So this box or block is running that encoding algorithm. So this is a video sensor. Apart from that, we have neighboring scalar sensor nodes. These are all the scalar sensors, something like this. You have a video, and this might be the neighboring scalar sensor nodes, is it? Video sensors are typically working at lowest possible resolution, or maybe they are in standby mode most of the time, because it is very costly to run the video sensors all the time because of the energy consumed by video nodes. But scalar sensors are low power devices, they can work continuously. So here we are assuming that video sensors or video nodes are in standby mode most of the time. And scalar sensors are all the time capturing because they are low power. We can ask the scalar sensors to work continuously 24/7. Scalar sensor, if they identify something, they can send a message, they can broadcast a message in the neighborhood. And all the video sensors, upon receiving that message, can become alert. Alert in the sense they will move away from standby mode and they will start capturing the video. Is it? So you can see that there is a trigger input. So this is a trigger input coming from other scalar sensor. They will trigger the video sensors and video sensor will start working. Otherwise, they were in standby mode, just to ensure that we can conserve some energy. Okay, so this I have explained. This is the detailed breakup of the things. You can see this is 802.15.4 base MAC. Below that we have radio, something like CC2420. On top of it we have routing, so network layer, which is playing with multiple parameters like deadline and energy. These are two important parameters which are used by routing protocol to forward the packet. On top of it we have video application, or uske upar we have video sensor manager, which works with some of the parameters like frame rate, resolution, group of pictures. GOP is actually group of pictures. And you can see that this video sensor manager also passes some parameters like frame type and deadline. After encoding the video, the frame is sent to video application will send it to routing layer, and on the way they will be sending the frame type, yani ki whether it is a key frame or WZ frame, or whether it is I frame, P frame, B frame if I'm using MPEG. So that kind of information is forwarded, and routing layer will be exploiting that information. I frame है तो उसको किस तरह से हैंडल करना है, P frame है तो किस तरह से हैंडल करना है, likewise. So that information is forwarded from upper layer towards the lower layer, and where those lower layers will use it for efficient forwarding or QoS aware forwarding of those packets. And apart from that, the video sensor manager is getting some inputs, sharpness and criticality. Again, these are all, like, this is incorporated in this framework, but you may not use this kind of terms. You might change it slightly, but in this framework, I'm using these two terms, sharpness and criticality. Sharpness indicates the alertness of a video sensor. A very highly alert node means it is capturing at highest frame rate, highest resolution. But if the event is not very critical, is it something is happening but बहुत ज़्यादा important नहीं है, then I can ask the video sensor to work at lower frame rate, like maybe 4 or 5 frames per second, lower resolution like 40 by 30, 40 pixel by 30 pixel suppose. If it is very important, you find that this important event is very important and some important information is to be captured, you might increase the alertness of that node, is it? So that alertness is an input to video sensor manager, and based on alertness, it adapts the frame rate and resolution. Okay. And these are those boxes. Detection history is something which maintains the last time उसने कब event detect किया था, it maintains this history. Backup set computation is actually your redundant overlap identify करने के लिए box है. Then we have frame comparator to identify that you have captured a video frame. Basically, whether that frame contains any unusual activity happening. So that unusual activity happening, वो आपको करना है, तो you can subtract the background and compare it with previous frames and identify whether a new object has been identified in this frame or not, and likewise. So that kind of processing can be done. So this frame comparator is responsible for that. Okay. So these are various components of the video node. And these are all the parameters which we are playing with. Alertness जो आपको बताया था, frame rate, resolution, whether some object is detected. So intrusion detection, basically ID, it's a parameter which identifies or which indicates that something has been detected, is it? Neighbor alert is the trigger which you are getting, because look, after all, you are supposed to have an algorithm which takes all these parameters into consideration and takes some action. So that is why these are all parameterized. Detection history, quality control messages, backup set is actually the set of redundant nodes, is it? And using this equations, we were calculating the alertness of a node. Alertness will be 0 if the FOV we already described. If it is covered fully by other set of active nodes, it means I can go to sleep. If I am going to sleep, iska matlab my alertness is 0, is it? But if my FOV is not covered, then probably I need to work at some level. At what should be my alertness? You can see that it is calculated based on neighbor input, history, quality requirement, and likewise. This is how we are deciding the alertness. And then that alertness is translated into frame rate, and we will identify the appropriate frame rate at which the camera should work in order to have this level of alertness. Exactly that way we will identify the resolution at which the camera should work. And you can see that there are many cameras available. OV 2620 or 2640. It is a camera which supports resolution ranging from 1600 cross 1200 to 40 cross 30. Is it? So you can identify, you can configure this camera to work at 40 cross 30, or it should work at 1600 cross 1200. Is it? And likewise, similarly, there are other cameras which also supports many other resolutions. So basically, we can control the resolution dynamically. Based on the inputs that we are receiving, can I control the resolution dynamically? Lower the resolution, lower is the bandwidth requirement. Lower the frame rate, lower is the bandwidth requirement. So the objective is to ensure that you are working at minimum acceptable frame rate and minimum acceptable resolution level. Okay, that is the objective. Dynamic GOP size. This is something that like, do you know what is GOP? GOP is group of picture. Like if I use MPEG or H.266, I'll be using I frame, P frame, B frame. So distance between two I frame is called as the GOP size. Typically it is 15, 21, etc. These are possible GOP values. What effect does it have on the transmission? Larger the GOP size, yani ki distance between two I frame is large, like suppose it is 100. What effect does it have? Lower bandwidth requirement, because the size of I frame is very large compared to P and B frame, because P and B frame only carries the differences, whereas I frame is an intra-coded JPEG frame. It is quite large in size compared to other frames. So smaller the number of I frames that you transmit, lesser will be the bandwidth requirement. So if your GOP size is very large, your bandwidth requirement will reduce. GOP size is small, quality will be better, but at the same time your bandwidth requirement will increase. The question is, can we play with GOP size dynamically? Is it possible technically to do it? Look at the importance of iframe. Iframe is basically used to capture the scene change. Is it something important happening? It should be captured by iframe, and subsequent 10 to 12 P frame and B frame can generate or decode the video based on the iframe. So basically iframe is important whenever there are changes in the scene. But think about a surveillance system, a CCTV camera or any kind of video surveillance system. How many times you will find scene change? Never. Is it? But if some object is detected, then only you will find that there is some new things are captured. Otherwise, at night time, suppose you have a CCTV camera deployed in your classroom, your institute classroom. During daytime, you will find that there is some activity happening, and every time you need to generate iframe. What happens at night time? About 13 to 14 hours, we are not using that classroom, and no activity is being detected in that classroom. Do you think that sending iframe periodically with GOP size of 10 to 12 will work or is acceptable? It is not acceptable. So why not to have iframe introduced dynamically whenever there is a change in the captured frame? So you just need to identify, compare current frame with previous frame. If there are some changes, then introduce iframe. If there are no changes, nothing is changing in the environment, nothing is changing in the captured contents, do not transmit iframe for very long. In turn, will be able to reduce the bandwidth requirement. So exactly the same thing is implemented here also, or it has been suggested here. GOP can be varied dynamically. Whenever a new object or something new is detected in a frame, key frame is introduced, key or iframe is introduced, else continue generating and transmitting the P and B frame or WZ frames. This is how it is done. Apart from that, we have upper and lower bound on GOP. ठीक है, आप iframe नहीं डाल रहे हो, does not mean that you have 1000, your GOP size is 1000. We can have some upper bound like 100. After every 100 frame, you need to have iframe, something like this. Is it? Can be done. Getting it? These are some of the possibilities. Okay, now I'll talk about the overlap computation. So FOV I've already explained. Look at this diagram. Like quickly, I'll explain what exactly is a coverage redundancy, how to identify coverage redundancy. Look at this camera sensors deployed. V1, V2, V3, etc. These are all cameras, and the triangles jo bata raha hai aapko, it is the FOV of a camera. Look at the camera with solid triangle, PBC, this triangle. So this is the triangle under consideration or camera under consideration. Can you identify the set of nodes which collectively covers the FOV of this triangle? There are many algorithms developed to identify this overlap. But here you can see that this is the central line. This point G is the center of gravity of this triangle. GP, that is this red point, is actually a central point between G and P. GV is a central point between G and this point. So we have three G points, G, GP and GV. This algorithm, one which is explained on the slide, is if any other camera covers any corner point and one of the G point, it should be included. So like you can see that V1 covers B and GV as well as G, is it? So I'll say that V1 is part of my B set. So you can see BG set, uske andar V1 aa raha hai. V1, V2, V5, these are three different nodes which covers point B and one of the G point. Similarly, PG is the set of nodes which covers P and one of the G points. So only V6. Okay, V6 and V3. Okay. So PG के अंदर ये दोनों है, and similarly CG is the sensors, the camera जिसका FOV covers C as well as G point, and likewise. So this is how we have computed. So the backup set of this sensor, the solid line triangle, is this V1, V3, V4. These three nodes collectively captures or collectively covers the FOV of this camera. So अगर वो तीनों node चल रहे हैं, तो I can ask this PBC वाला node to go to sleep. Similarly, V2, V3, V4 is also a backup set. Backup set in the sense, collectively they are working as a backup for this node. It is like this. V3, V4, V5 and likewise. These are all the backup sets which I could compute using this algorithm. There are many such algorithms. Okay, but there is a method available to identify the coverage overlap. Identifying the coverage backup set, coverage overlap will help you in duty cycling the nodes. And the overall objective of duty cycling the node is to save energy. I hope you are getting it. Routing protocol, like I can talk about routing protocol for days, but I don't want to get into it. I already talked about routing protocol slightly in one of the earlier slides, that we need QoS aware routing protocol. QoS aware in the sense something which can take care of the packet requirement and accordingly handles the packet. is it? So communication protocol, I'm not getting into much, but this is also equally important. I cannot discard the routing protocol. आप RPL use कर लो, no issues, but see whether RPL can fulfill the requirement of application. If yes, you can. If no, maybe you need to redesign a routing protocol. Similarly, quality of service, video aware QoS MAC, in the sense a MAC protocol which is video aware, in the sense it can understand the video. At the same time, it can supports the required quality of service. So that kind of MAC protocol is required. And we already seen some of the provisions or some of the alternatives available, like 15.4 okay, 15.4e, 11e, 11ah, and likewise. These are all the alternatives available. Apart from that, you can think about wireless HART, Z-Wave, then BLE, maybe LoRa. LoRaWAN is also one of the options which you can use at Mac, but see whether it can fulfill your requirement for this application. LoRa certainly cannot work, because LoRaWAN, what is the bandwidth? Anybody knows what is the bandwidth offered by LoRaWAN? LoRa is long range communication. So it is a MAC protocol or a transceiver which supports long range communication. It is one of the possibility of underlying protocol for IoT. But the data rate supported is in terms of few bytes. अगर आपको एक image भी भेजनी है, तो it will take half an hour to send one image. It is that low in data rate. So you cannot use LoRa, is it? And likewise, you need to think which MAC alternative or MAC suggestions can fulfill your requirement in terms of the bandwidth requirement, quality of service requirement, and etc. Based on that, you need to decide your transceiver. If required, you can tweak that transceiver or that protocol also. But there is something which you can do or contribute here also. Okay. So this is a brief overview of video surveillance architecture using IoT. Again, like as I started with that, okay, like this shows one simulated environment, but this is how it was done. The complete framework was constructed and it was simulated also, but we'll not be getting into that detail. So I suppose I'm done with my contents. To summarize, design of surveillance framework for this kind of environment is very challenging, and we already looked at the list of challenges which one need to look at. Especially if you are a designer of this kind of framework, you need to take care of each and every challenge that comes up. Energy efficiency is very critical, and that is why you can see that anything that we have done in this framework was for conserving energy. And still there is scope available for optimization in various aspects of design, like video encoding you can contribute. Still there is scope of video encoding, something to contribute in video encoding. Capture redundancy, many algorithms have been developed, but still you can maybe improve upon it. Duty cycling the camera, so you can have a maybe system by which you are duty cycling your camera nodes. And communication protocol is always a open issue. Whatever kind of protocol you design, then also it is not sufficient to take care of a given application. So for that application, maybe you need to customize existing application, existing communication protocol, or maybe you need to redesign the communication protocol. So these are all the areas where you can contribute something. So I suppose I'm done from my side. Again, जब मैंने बताया था, I had an option of summarizing different applications of IoT for for military applications. But again, that talk would have been quite abstract. So I thought about having this kind of talk, looking at the audience, because audience are faculties. अगर वो students होते, तो I might have gone the other way, where they are interested in the application, the way the applications are working, rather than getting into the details of the design. So based on the audience, I thought this kind of session would be useful. So I'm done. If you have any questions or any discussions, I'm open to questions and discussion.
Yeah, thank you very much, sir. All the participants are requested, if you have any query, you can write on the chat box, or if you want to ask also, you can unmute and ask, as is the end of the session. Any query, participants can write, or they can ask through mic as well as.
Okay, look, I understand that the session was very conceptual. So somebody who is from this domain they will find it very interesting. But somebody who is not from this domain, in the sense you are not working at multimedia encoding, you are not working in protocol design, then you might find that it was maybe quite complex. क्योंकि इसमें थोड़े topics या terms ऐसे थे which I was making assumptions. I can understand.
Professor, I have a question.
Yeah, please.
In the coverage redundancy based on FOV, can you please go? Can you show that slide?
Yeah.
It is.
This one?
This one.
Yeah.
Okay, this is very nice explanation. My doubt is,
and
you are dividing into based on the redundant points. Am I right?
Yeah.
For example, V1, say V2 and V5.
Yeah.
In case my intention is to sense the area which is not within the bold line, block line.
Okay.
Then how can I switch off, or how can I use the duty cycling in that case? Okay, so my intention is the coverage is whatever is there in the solid area, then it is okay.
Yeah.
But in case if I concentrate only that area, the video camera covers even beyond that.
Yeah. Okay.
Then
so
I
got your point. I got your point. Yeah, I got your point. Look, I have explained the FOV. I'll go back to this.
Yes.
In FOV, we have looked at this D. D is the distance, or basically it is called as depth of view. Can I say that the depth of view of a camera is finite? No.
Yes.
No. A camera, agar aap, suppose you have one camera, you focus in one direction, you will be able to see till kilometers, you will be able to see that some contents are being captured by the camera. But D is the depth up to which you can identify an event at significant quality level.
Okay.
But otherwise, I can say that camera ka you can never say that it can capture only up to 13 meter. Anything happening at 13.5 meter, you will not capture. It is never, never like this.
Fine.
Yeah.
But anyway, for any sensing area, we are defining the sensing field.
Yeah.
This is the field area.
Field FOV is the field area which we are capturing with that particular camera.
Oh, anyway, but if anything goes beyond that, then it goes beyond the field area.
Yeah. But look, anyway, I got your point. But for theoretical modeling or for algorithmic modeling, we need to have some finite depth of view. We need to have a finite FOV. Then only we can model it.
Yeah, okay, definitely. So what you are telling is correct. I'm not asking against that. My doubt is.
Yeah, you are correct in that. For that matter, like suppose if I switch off this node, PBC wala triangle solid line, and something happening slightly beyond the FOV, surely the node will not capture it.
Yes.
Because for theoretically we have assumed that the depth of view is this much only.
Yes. So if,
and we need to have some finite value for the depth of view. Is it?
Okay, all the area to be concentrated is only the solid line, the area within the solid line. Switching off the other video sensor, it is okay. But if it is slightly outside and if you switch off the
got
video,
your point.
That's why.
Yeah, exactly. Yeah, you are correct in that matter.
Okay.
But for modeling, like algorithm design, you need to have some finite value. That this is my FOV, and I'm considering only this FOV.
Okay. Thank you. Thank you, Professor.
Yeah.
Thank you.
Yes, any other question?
Yes, any question? Chat box also, I could not see any question.
I hope most probably presentation has covered almost all the topic. Sir, really, as a faculty, really, there were a lot of good research topics Sir has suggested, and I think the session will be helpful for all the faculties. And obviously, I like to inform all the participants that the attendance link is shared in the chat box. Before closing the event, closing this session, don't forget to use the attendance link to fill your data, because once you exit the meet, the link will not be visible to you, right? So all the participants are requested to use the links which is there in the chat box and give your attendance for this session. Sir, once again, I like to thank you for your wonderful presentation. Indeed, it will be helpful for our participation. The next session is at 12 o'clock. I hope the link is already shared to you. We will meet at 12. I request all the participants to join. Yes, sir. Yes, Bhargav, sir.
1:30. Next session is at 1:30.
Okay. Okay. The next session is 1:30, and I request all the participants to join before time, so that we can start the session on time. Thank you. Thank you very much, everyone. Yes, this is the end of session. You may leave.